Okay, so this is going to be a real quick reminder of this idea of atomic theory, because we're going to use atoms and the idea of atoms moving around and transferring energy and all of that in our study of thermodynamics. So you probably recall that matter, of course, that's the stuff we're made up of, right? The molecules and the atoms and the compounds, all those wonderful things that we're made of. And you might recall when you first learned about atoms that although we know now that they're not the smallest particle, right? We know about electrons and protons and things inside of the atoms, and all those fun things. We're going to kind of still use that model in our sort of macroscopic discussion of thermodynamics. And so if we take the idea that atoms are the smallest piece of an element, we want to remind ourselves of a few things. Terminology lecture today. So an element is a substance that we basically can't break down into any other substance using chemical means. So it is the base of a substance that we can't break down any further by chemical things. So gold, silver, helium, hydrogen, the pieces, the elements of the periodic table, those are our elements, okay? So that's the idea of an element. Similarly, a molecule is the smallest piece of a compound. All right? So an atom is the smallest piece of our elements. The molecules are the smallest piece of our compounds. And remember, compounds are things that are made up of two or more elements, right? So, for example, a compound would be like sodium chloride, table salt. It's made out of the element sodium and the element chlorine. I can do something chemically to break those two apart into their smallest elements. And if they're together, one piece together is, of course, the molecule. So just a quick reminder of kind of some of that terminology. Now, matter, we know, comes in 3 phases. So let's just remind ourselves that we're going to worry about. There's that plasma phase of matter, but we're going to just deal with solids, liquids, and gases. And you learned about some of these oops, that's not how you spell gases. Yeah, it is. You've learned about some of these features in Physics 1, just to review some of the things that we want to consider in a microscopic view, whereas in Physics 1 we talked about them more in a macroscopic view. Now we know that when atoms come together, that there has to be a little bit of a repulsive force, right? When we first learned about atoms, we know that electrons are kind of in that outer shell, they are in that outer shell, electrons are in that outer shell. And if electrons are coming close to one another, they're gonna repel one another. So there's a little bit of repulsive force. And there's also chemical structure that's keeping these chemicals together. And so for a solid, we know that there's strong enough bonds that they hold tightly together, and there's only slight vibration. So there's still that minimum distance kind of based on that repulsive force, but there are these stronger bonds that sort of hold those atoms in place, and they only vibrate kind of in fixed positions, right? So it forms sort of that crystal lattice. You can imagine, if you have these atoms, they're sort of together in this kind of crystal lattice, and they're only oscillating in those fixed positions. Liquids, the atoms can move around a little bit more around each other. And then, of course, gas, they're a little more loosely bound. Gases, completely free. They move all over. They spread out in terms of their taking up that space. So just sort of those reminders of how solid, liquids, and gases might look, that motion that's happening as those molecules or atoms are moving around. We probably have some background in that based little bit on the temperature. That's what we're going to dive into. So we're going to look at these things more in that microscopic view. But I just want to do a quick review of those 3 phases of matter, some terminology that we want to remind ourselves of, and we'll dive right in. Good job.